Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Izuddin bin Shahidan. I will be presenting about final project PSM1 with title IoT Enable Visitor Management System for Heritage Buildings. My supervisor, Associate Professor Technologist Dr. Muhammad Mutada bin Muhammad. For my contents, which is introduction, literature review, system development methodology, requirement analysis and design, and the last one is conclusion. So for the introduction, the IoT-enabled visitor management system for heritage sites is designed to provide an efficient, real-time platform for tracking and managing visitors. The system will use motion sensors to identify unregistered entry and RFID technology to track registered visitors. In order to enable proactive crowd management, administrator will have access to a dashboard that shows real-time visitor data and issues notifications when there are too many people at one time. So we move to problem background. Heritage buildings or museum requires careful preservation for historical artifacts and structures. However, most of these places struggle with managing large crowds of visitors, especially during peak hour or public holiday. Currently, many heritage sites use ticket system or entry logs to monitor visitors' number. In this system, visitors may be required to purchase a ticket or register their entry manually. So the first problem is too many people in one area can harm historical artifacts. It can increase temperature caused by collective body heat of visitors. And the second one is the lack of real-time data on visiting numbers, which can make avoid these harmful effects. And the third one is physical contact and accidental damage. Next, we move to the project aims and objectives. So the aim of this project is to develop an efficient and automated IoT-based visitor management system that monitors visitor flow, avoid overcrowding, and protect historical artifacts at, inside the heritage building. For project objectives, it includes three, which is the first one is to monitor visitor flow. The second one is to develop a platform that can get real-time visitor tracking. And the last one is to test and evaluate efficiency and effectiveness of the IoT-enabled visitor management system. It can prevent overcrowding and ensure artifact protection. So for the project scope, the first project scope is the system is developed for use within heritage sites, including museums and historical buildings. The second one is visitor tracking will be integrated using IoT sensors such as RFID and motion sensor to monitor real-time visitor counts. So the last project scope is alerts will be generated with the visitor counts reach a certain threshold, notifying administrator through the web interface to manage crowds and ensure compliance with building capacity limits. So we move to the chapter 2, which is a literature review that contains current system analysis. So current system analysis, I have two types, which is the first one is manual methods. Manual methods, it have overcrowding control So this control due to the lack of the real-time monitoring capabilities. Manual approaches take longer to detect overcrowding conditions that could harm historical artifacts and structures. Administrators often rely on visual observation, which is unreliable. So for this second one is digital application. Digital application includes lack of integration that contains current digital platform frequently lack without IoT integration. They do not integrate visitor tracking, alert generation, and data analytics to managing heritage buildings. Next, we go to the technology used for development, which is the first one is HTML. HTML is a hypertext markup language. Is the code that is used to structure web page and content. For example, content could be structured with a set of paragraphs using image and data tables. The second technology, I use Node.js, which can have a back end that handle data communication, processing, and integration with IoT device. The third one is JavaScript. So JavaScript is a scripting language used to develop web page with user can interact. So we go to the chapter 3, which is the methodology. So for the methodology, I use the the agile methodology. So for the first one is requirement gathering analysis. So gathering requirement have a determine network needs and require IoT device such as motion sensors and RFID tags. It can include PHP, HTML, JavaScript, and Node.js. So the second one is design of the system, which include tools like UMR diagram, use case, activities, and sequence diagram. The third one is implementation and coding, which can integrate IoT hardware such as motion sensor and RFID for real-time monitoring. The fourth one is testing. So for the testing phase, it ensure an accurate real-time visitor count and testing alerts notification when visitor threshold exceeds. The deployment one is can configure a cloud server for the application. So for the hardware, can connect live testing in a test environment for heritage building. So for the last one is maintenance. After overall the phase, uh, we can make maintenance to have control the system and the hardware for the long term. Next, we go to the tools used for for development. The first one is Raspberry Pi. Raspberry Pi can is a Raspberry Pi is a hardware that can controller to process and transmit data from IoT device. So the second one is Arduino. Arduino is a microcontroller to connect IoT sensors to the system. For the last one is RFID. RFID is in an IoT sensors for real-time visitor count and motion detection. So we go to the chapter 4, requirement analysis and design. So for the use case diagram for the IoT-based visitor management system outlines the interaction between users such as admin, visitors, and security personnel. Key use cases include real-time visitor tracking, crowd monitoring, and alert manage for capacity management. Administrators and security personnel perform tasks like assessing report, configuring threshold, and monitoring visitor data, ensuring efficient operations. The diagram highlights the system role in optimizing visitor management and preventing overcrowding in heritage buildings. Next, system architecture. The system architecture of the IoT-enabled visitor management system integrates IoT sensors, a cloud-based database, and a web application to enable efficient monitoring and control of visitor activities in heritage buildings. IoT sensors like motion detection and RFID readers collect real-time data at entry and exit points, which is transmitted to the cloud for processing and storage. The web application serves as the user interface, providing features for visitor registration, real-time monitoring, and alert notification. Admin and security personnel access dashboards to manage operations, while the system ensures data privacy and scalability through secure cloud servers and encryption protocols. Next is interface design. So for the interface design for the IoT enabled visitor management system, prioritize usability and clarity across three primary user roles, which is visitors, admin, and security personnel. Visitors can access a streamlined registration process, view heritage information, and download a digital pass. Admin users benefits from a comprehensive dashboard, allowing them to manage visitors, generate report, and configure system settings. Security personnel have dedicated features for monitoring visitor activity, receiving real-time alerts, and reporting incidents. The system includes intuitive navigation with a consistent top bar. Like you can look at the status, which is whether it's good or not, and also it can see the visitor count, how many person inside the heritage building. This clear content organization, visual elements like icons and charts, and professional scheme ensure a user-friendly experience while supporting operational efficiency. So for the conclusion, using IoT sensors can help for making accurate tracking, creating a web-based administrator interface, and tracking visitor counts. It also can maintain the building structure and artifact objects inside the building with more secure and safety. That's all for my presentation. Thank you.